There are basically two ways that we can find the speed of a reaction. First way is by measuring the quantity of the product that is formed in a fixed interval of time, or we can measure the amount of reactant that is remaining over a fixed interval of time. So let's look at the first way. Let's say over a period of time you measure the volume of gas and the results are being tabulated. After tabulated, you actually draw the graph and the graph looks something like that. So it is important for you to know how to interpret the graph. Firstly, if you can see at the initial stages, the gradient is rather steep, meaning that the reaction is very fast initially. Over time, it gets more gradual and eventually it reaches to zero. The gradient reaches to zero, meaning that the reaction has stopped because the limiting reagent is probably used up. Okay, then if you are looking at the second way, which is by measuring the quantity of reactant that is remaining, I just want to point out that in the diagram they usually have a cotton wool at the neck of the conical flask. The purpose of the cotton wool is to actually stop the acid spray loss but still allow the carbon dioxide to actually escape. So the mass loss is actually due to the carbon dioxide escaping from the reaction. So this is after tabulating, and then you plot the graph. Important to take note of the axis and the units. Please don't miss that one out. This is how it looks like over time. So in this graph, you should also be able to see that initially that the gradient the gradient is steep, and then it gets more gradual, and over time it becomes zero. So initial stages, very fast reaction, and then it slows down, and eventually the reaction stops when all the limiting reagent has been fully used up.